Hello, in this video we're going to look at the linear linked list implementation of a queue. So now let's take a look at the linear linked list. So now we have a linear linked list here. And remember, queue has two positions of interest. One is the front, one is the rear, and you enter from the rear and you remove from the front. So for a linear linked list, we have to model two ends there. When we model two ends, that means we need to have the head pointer and the tail pointer. Alright, now let's see which one to be the front, which one to be the rear. So I'll just randomly pick one. So I'll first, this is my pick, this is the front, this is the rear. Okay, now let's take a look at the enqueue operation. To enter from the rear, okay, so you simply do this. You can imagine it's just like this. Rear next equal to new node, and update your rear to this newly added node. That's all. So enqueue is super easy. And now let's take a look at the dequeue. Dequeue means I want to remove this guy, and easy enough. That's what it takes to remove this guy. Of course, remember to delete the memory, then link this head to the new front node. Alright, so that's pretty simple, and both operation doesn't require you, neither operation requires you to traverse or anything, so efficient and easy to implement. And now let's take a look at another possibility. So let's see if you have a linear linked list, and what if you're thinking about I'm going to choose a different front and a different rear, so just the other way around. So let's see, this linear linked list. What if you say this is going to be my front and this is going to be the rear? Now let's take a look at the enqueue operation. So to enqueue, you enter from the rear, so that's easy. Okay, you make this, okay, enter from the rear. That's pretty simple. You manipulate two pointers and you're there. And now let's take a look at the dequeue operation. Dequeue operation means remove the front. Now think about, how do I remove this one? In order to remove this one, I have to have a handle of this node, the second to last node, to set this pointer to no and delete this guy. Alright, I have to have a handle of this one. How do I have a handle of this one? Oh, I think the only way you can have a handle of this one is to traverse from the beginning. So that's not a very attractive solution because you have to traverse. Once you have to traverse, that means totally depends on how big the list is. If it's a big list, that will be performance penalty here for the traverse. Alright, and maybe you're thinking, okay, how do I get to this guy? If I have a previous pointer, if this is a doubly linked list, yeah, that's true. If it's a doubly linked list, it's fine. You don't need to traverse. You just have a handle of this previous node, and you can remove the front and set up your new front there. But here's a principle. If you don't really need a doubly linked list, you don't want to do that. You see, a linear linked list will just do a good enough job here, and because it's a position-based ADT, we only care about two positions. We only have enqueue and dequeue, so I don't think it really pays off to maintain a doubly linked list for a queue. A linear linked list will be fine, assuming you choose the right front and the right rear. The coding part is pretty easy. Once you choose the right front and right rear, we won't look at it. Thank you.